Hello my dear friends, welcome to our program for chemistry third secondary stage. Today we have an important session about electrochemistry. What's meant by this electrochemistry? What are the branches that we studied inside this one? And what are the examples that use it to produce electric energy from chemical energy? Let's go to start our session today and concentrate with me very well. Let's go. Today we have chapter 4, electrochemistry. We have here electrochemistry. It means what? It means it is a branch of science that care for studying the exchange conversion between chemical energy and electric energy. It's very important to know this. We have electrochemistry. Electro, it means electric, and chemistry, we have atoms, ions, molecules that react to each other to form electric energy, or to change from chemical energy to electric energy. And we have some cases, we have electric energy changing into chemical energy, okay, and vice versa. So the definition, it's very important to know this. We have the branch, the meaning of electrochemistry. It means it is a branch of science that care for studying the exchange conversion. Conversion, it means change between chemical energy and the electric energy by the chemical reaction, for example. And here we have the electrochemistry also through what? This reaction that takes place by an old reaction between us. We studied this before. We have oxidation and reduction reaction. That means what? That means oil rig. Mister, what's meant by oil rig? Oil rig, it means what? It means the reaction of oxidation and reduction. What's meant by this also? So we have here oil, it means oxidation. In the right hand, we have oxidation is loss of electrons. If I have losing of electrons here, it means oxidation in our curriculum here. Why? Because oxidation, it means a metal atom that lose 1 or 2 or 3 electrons, so it makes oxidation reaction or oxidation process. So here oil, the first part of this word, we have oxidation is loss of electrons or losing electrons. And the second part, we have rig. Rig, it means what? It means reduction is gaining electron or gains of electron. Gaining, it means a non-metal substance that take the electron and increase the number of negative charges, okay, on the energy level. During what? During the chemical reaction. To make what? To make oxidation and reduction. In the same time, we have oil rig. They are oxidation and reduction that's happened in the same time, in the same chemical reaction. To produce what? To produce electric energy. So the spontaneous redox reaction can be expressed by the following reaction. For example, we have Zn, it is a metal, and we have Cu, copper ions, positive 2. What's meant by each one of them? We have the metal here, a piece of zinc, and we will illustrate this after a period of time. We have Zn plus Cu plus 2, give us Zn plus 2 plus copper atoms. So the ions change into atoms and the atoms change into ions. Why? Because here we have oxidation and reduction process or redox reaction. What's happened here? Here we have what? We have the oxidation. The meaning of oxidation, losing electron of Zn. It means I lose 2 electrons, so the positive charge increase in this atom and it change it into what? Into positive ion. How many positive? Here we have positive 2. Why? Because it loses 2 electrons. But the second one, we have the copper, positive 2. It means 2 electrons that lost before, or it's found in the shape of ions in the chemical compound like copper sulfate, copper nitrate, copper hydroxide, anything of these solutions. So here the copper, positive 2, reduction process change to what? Change to copper atoms. So that's what it makes precipitation, for example. So this is the meaning of oxidation and reduction in this case. So after that, what is the oil rig again? Here we have the redox and we have the oxidation. The meaning of redox oil rig, it means what? It means redox, reduction. Ox, it means what? It means oxidation process. So here in this one, this is redox, it means what? It's lose, or we have gaining some electrons here and they lose some amount of energy. So the oxidation here, we have some parts here, like what? Like the activity that happened to make rusting, for example. Okay, so here this is what? This is the oxidation parts, and here we have redox parts. After that, here we have the oil is oxidation is losing electron. For example, again, we have Zn. This is called half reaction or half equation. So Zn0, it means one atom. It has no charge, or it is neutral charge because it is metal atom. That makes losing 2 electrons like this. So here we have Zn positive 2. It means losing the electron, it means oil. What's meant by oil? Last time, oxidation is losing electron. So here we have this equation. It is a half equation of oxidation or reduction. And the second one, here we have zinc atom loses 2 electron and the converter change into zinc ions at cathode. What's meant by cathode? Cathode, it means negative pole. In some cases of battery that we illustrate after a period of time. So after that, we have rig. It means reduction. It's the gains of electron or gaining electron. So Cu positive 2 plus 2 electrons that give us Cu 0. Means what? It means we have the ions of copper that makes what? That makes gaining 2 electron and change it into copper atom at anode. So here the anode, it means it is the opposite of what? Opposite of the cathode. It means positive pole. So after that, this one is the second half of equation. So we have 2 halves of equation. This is one of them, and the last one is Zn. Change into 2 electrons and Zn positive 2. We will illustrate this after a period of time in the form of electrochemistry. So this is the basics of electrochemistry to understand it. After that, we have a small exercise like the booklet. So here, we have does each of half equations show the equations here or reduction. Which one is equation that represent the oxidation and which one that has reduction? Here we have the first one here. So this one, it's what? It's Mg positive 2 plus 2 electrons. So it gains electron or it takes electron. So it's called reduction. And after that, we have here, this is 2, negative 2 ions, and change into what? Into O2, oxygen molecule, and changed into 4 electrons. So it means what? It means oxidation. Why? Because here we have losing electron, 4 electrons that lost from this reaction. And here we have Zn positive 2 plus 2 electrons. It means what? It means reduction. So this reduction, it's happened in what? Happened in the anode, right? So here, this is Al positive 3. Means aluminum ion that has positive 3 charges. Here, it means positive ion of aluminium. And make what? And make gaining for 3 electrons. So here, this gaining of electrons, it means what? It means reduction also. And this one, mister, it's 2 electrons gaining here. So it is what? This one is reduction. And here we have this one. After that, we have losing electron here. So it is called oxidation and so on. So they are what? They are the oxidation and reduction. Concentrate with me very well here. To know the difference between these 2 halves of the equation and don't distribute between them. We have 2 Cl. For example, in this one. Here we have Cl. Cl, it means what? It means 2 ions of chlorine that happened or that found in what? In HCl, for example, hydrochloric acid, NaCl solution, anything of this. And here we have the electric energy or chemical energy that happened between them. So here we have Cl2 by losing 2 electrons from these ions. At what? At the cathode. Why? Because here it's changed into Cl2. It means what? It means molecule of chlorine. And losing 2 electrons like this, it means what? It means oxidation. But here, we have the electron is found here after the arrow. But here, we have the electrons before the arrow. To make gaining of these electrons, Al positive 3, for example, change into 3 electrons. And we have Al. It changes from ion, positive 3 ion, into what? Into the atom. So it is called the oxidation and reduction reactions here. After that, we have another exercise. Here we have oxidized and reduced. The basics of this part is very important for you. So here we have copper oxide and carbon. So the carbon change here into carbon dioxide. So it makes what? It's oxidized or reduced. So the carbon here, it's oxidized. After that, we have here the copper oxide. It's what? It's reduced. Why? Because here this one, it makes what? It makes this, the copper oxide, it's one of the chemical compound that lose oxygen here. Change from copper oxide to copper. After that, we have another one. Yes. Next, we have another one here. We have iron oxide and the aluminum. And here we have the iron oxide. Who can tell me the answer here? Iron oxide, here it changing into iron. Yes. Okay. So the iron oxide, it's what? Reduced. Because it loses oxygen here. And here we have aluminum changing into oxide. So we have here this the aluminum here. So this one is right, because we have the iron oxide is reduced. Reduced, it means lose oxygen. And oxidized here, it means gain oxygen. After that, you have the carbon monoxide. It is one of the oxides of the carbon. Change into carbon dioxide. It means I increase the oxygen here. So it is oxidized, Mr. Right. So here after that we have iron oxide, lose oxygen. So it is reduced, for example. And here we have the correction is right. Next. And here this is zinc oxide and the hydrogen. Hydrogen change into water. It means what? It means hydrogen gain oxygen to change into water. The water is what? H2O, Mr. Right. Excellent. So here we have the hydrogen and oxygen in water molecule. So the hydrogen change into water, so it is reduced here. After that, we have the zinc oxide, lose oxygen here, so it is what? Here we have this zinc oxide, here the hydrogen, it's oxidized, and the zinc oxide, it's what? It's reduced. After that, the last one here, we have magnesium and the oxygen. It's very easy. We have the magnesium oxide. Magnesium is oxidized and the oxygen is reduced. So the correction here is right. Well done. So the different types of cells, okay, converts chemical energy to electric energy. This is the device that we have in this chapter to study it. We have many types of redox reaction batteries or simple cell. And we have different types of cell that convert chemical energy to electric energy. Why? Because the electric energy produced from the redox reaction. What's the redox reaction? Oxidation and reduction of this reaction. Electric energy through the redox reaction that are what? That are number one, that called galvanic cells. And the second one, we have electrolyte cells. Again, we have two main parts or two main types of these cells. Galvanic cells related to Galvani. It's the scientists that invent this one. And we have electrolyte cells that makes electrolyte solution that produce the electric energy due to the chemical reaction or through chemical reaction of redox reaction or oxidation and reaction. We repeat this one. Reduction, oxidation every time. Why? Because it is the source or the main source of electric energy from the chemical energy. If I have redox reaction, I have electric energy and electrolyte in the same time. But if I have no one of them, if I have organic compound, if I have benzene, for example, or vinegar, or anything like this, I have no electric energy. It is very weak one, okay, to make or to produce electric energy. It's good to see the first one. We have galvanic cell. Galvanic cell, it is an electric cell. Each time we have the definition of these cells. The galvanic cell, it is a type of electric cells from which we can obtain electric current as the result of spontaneous oxidation, reduction, reaction, as the example of Daniell cell. This is the shape of this one, and it's very important to know the drawing and the shapes of each type of these cells. The first one, it's like the car battery, the same idea. So here we have what? I need a source of chemical reaction. This is the beaker, and it contains SO4 negative 2 and Zn positive 2. It means ZnSO4, zinc sulfate. And after that, we have the copper sulfate, and here we have the copper cathode here, and here we have the zinc anode at left hand side. So the zinc anode, it's a piece of zinc that connected to what? Connected to the voltmeter to see if I have how many volts of the electric energy. So the copper is cathode. So here 2 copper in cathode 1. Again, we have 2 halves of the cell. We have 2 parts of the cell. The right hand, we have copper sulfate solution, because it's what? It has ions and it makes electric energy with what? With zinc sulfate. And between them we have a salt bridge. What's meant by salt bridge here? Salt bridge, it is a part, it is a tissue or a paper or a tube like this that full of potassium chloride solution. Again, salt bridge, it has potassium chloride solution. Or if I have no potassium chloride, I need any type of salt, even the table salt. If you make the solution, the table salt, and you make wet the tube or fill this tube from 2 parts here, so it is called what? It's called salt bridge. To make what? To make connection between the 2 halves of the cell. So after that, the copper at cathode, and we have zinc at anode to make the chemical reaction between them. If I have salt bridge, if I have no salt bridge, we have what? We have no reaction here. So here in the first part here, zinc change from zinc parts or zinc atoms into positive 2 ions, and it dissolve inside what? Inside the hydro or H2SO4. So here this is the solution or reaction between the zinc and H2SO4, sulfuric acid. In the other parts, we have copper 2 SO4, we have CuSO4. It's what? It is one of the types of electrolyte, or it is a solution that produce what? Gain electrons. To make what? To make ions here, or lose the electrons here to make ions positive 2, and it moves again to the solution. This reaction and these parts, the electron move through what? Through the reaction, through the salt bridge, and through the wire after that to make electric energy. So the source of electric energy is what? Is electrons that lost or gained from this reaction. This is about Daniell cell. After that, we have this cell here. Again, this one is Zn, and here we have in the other part we have Cu. So here Zn rode in ZnSO4 solution. It must have the same solution of the metal here. If I replace the zinc by what? By aluminum, I need aluminum sulfate, for example, or aluminum nitrate, any one of the metal solution. And here in the second part, we have Cu rode, it's CuSO4. If I move out this copper and I put another metal, like what? Like iron, like any one of these metal that less active. So I need the solution of the salt here of this metal. After that, here we have the voltmeter. It's 1.1, for example, okay, volt. And here, this is the meaning of voltage here, or the production of the electric energy from the ions here. The first one, again, in this beaker, we have Zn positive 2 and SO4 negative 2. This is ZnSO4. This is the ions of electrolyte number 1 at left hand side. And the second one, we have the SO4 and CuSO4. It's found here or dipped inside CuSO4 or copper sulfate by what? By the copper at cathode. After that, the oxidation reaction at anode could be expressed by the following equation. Here we have a very important part. In your exam, I need you to write the equation and I need you to know which one is anode, which one is cathode. Or in another word, we have the oxidation reaction that happened in which parts. The oxidation happened in which part, which pole, positive or negative, which part, the cathode or anode. And I need every one of you to read this part very well and to write the equation many times to solve these problems. So here, the oxidation reaction at anode could be expressed by the following equation. Zn change into Zn plus 2 plus what? Plus 2 electrons. Why? Because it loses 2 electrons and change it into positive ion zinc ions. So this is the first one that's happened in the cathode. And after that, we have the second one, the reduction reaction at cathode could be expressed by the following reaction. At cathode here, because it gaining 2 electrons. Cathode, it means it has large number of electrons here. So here this is Cu positive 2 plus 2 electrons, and here we have the copper ions from the copper sulfate changing into copper atoms and make precipitation. So after this one, it's the reduction reaction. And the first one, we have oxidation reaction that happened at anode. Anode, it means positive pole. Cathode, it means negative pole. In this part, the flow of electric current between two halves of the electron, of the cells. Here, it's stopped when all zinc metal dissolve in the zinc half. Why? Because the chemical reaction will stop. Because we have no electron to move. Because I need the electric energy from electrons. This is the reasons of this part. Again, we have the flow of electric charge here, or electric current between two halves of this cell. It's stopped when the old zinc metal dissolve in the zinc half. Why? Because zinc, it's eroded. Eroded, it means what? It makes erosion, or it's finished from this reaction between zinc and zinc sulfate. So it is dissolved inside. And after that, we have no zinc pool, so we have no reaction. So after that, I have no electric energy. So the flow of electric current for last time is between two halves of the cell stopped when all zinc metals dissolve in the zinc halves. After that, we have the reaction in the galvanic cell. Contains any two elements. We have any two elements from what? We have zinc. Any one of them, we have a form of this cell. This is the equation of the cell. I don't need arrows. I don't need the reaction. I don't need the product or reactant, but we need here Zn0, it means Zn metal or zinc metals. The rod of zinc. We have one part like this. We have the line between Zn0 and Zn positive 2. It means it dipped inside. This zinc rod dipped inside the solution of zinc sulfate positive 2. And here we have two parallel lines that represent what? Represent the salt bridge between them, right? So the salt bridge here, it means two parts like this parallel to each other. And here we have copper positive 2, or copper metal dipped inside the solution of copper sulfate solution positive 2. So here, this is the first one is the cathode and the second one is anode. After that, what is the salt bridge? Salt bridge is very important for these cells, Daniell cell or galvanic cell generally. We have the salt bridge. What's the importance of this one in the galvanic cell? So here, the galvanic cell, or the importance is salt bridge is U-shaped glass tube filled with salt solution, okay, NaCl or Na2SO4. Why? Or KCl, for example, or any type of the salt to make what? To make connection between the two halves of the cell to move the electric energy inside. So the salt bridge is the U-shaped glass tube filled with salt solution, okay, NaCl or Na2SO4. After that, by which its ions don't react with the ions of the two halves as well as the electrode materials. This one is very important information for you. By which its ions, the ions of what? Of the salt in the salt bridge don't react completely with the ions. Why? Because I need to make electric energy between just two halves. But what is the function of this salt bridge, mister? We have a connection between them. So we have the electron that move from the first half to the second half. Yes, to move or to pass the electric energy only. Again, we have the electrons here or ions of the NaCl to pass the electric energy between two halves without enter the chemical reaction. So here Zn dissolve or make reaction with ZnSO4 or dissolve inside because we have SO4 negative ions. So here the two halves as well as with electrode materials. We have no reaction between them. It just what? Just connect between the two halves of these cells. So the importance of salt bridge. Number one, it connects between the two halves of the cell without allowing the direct contact between them. It just help her to make this reaction or just help her to make or to pass the electric energy from the first half to the second half and pass to what? Pass to the wire. After that, another importance of this one, we have the neutralize, okay, or neutralization between. It neutralizes what? Neutralize the both of positive pole and negative pole. If I have an acid or base in each one of them more than the other, or to stop the reaction, it makes a neutralization to pass the electric energy or electrons from the first half to the second half, from the positive pole to negative pole. Through what? Through the solution. Because we have the solution, it needs what? It needs a type of electron that move or free electron to move to produce electric energy. Dear friends, I hope to enjoy your time with us. You have many things to study in this chapter. It is very easy to study. It's very easy to make this information and to study it for your exam. Till we meet again in another session. Thank you and goodbye everybody.